All right, so the first one, there are probably a million places you could get this wrong. The first one is right here. You have to do -3. Now, this is not this. This is -3, which is +9. This is not. This is -3. So it's a -9, right? You're not squaring -3. You're squaring 3 and you're subtracting it. That's the first mistake that people will make. The second mistake will be to distribute this. You do not want to do this. Even though you have the calculator, don't distribute there. Order of operations says that you must do the parentheses, right? Parentheses come first. Now, I'll tell you bluntly, because I am the one grading your final. If you violate the order of operations there, I understand you can take the calculator out and you can do 7 times 86 and 7 times 88 and subtract them. If I see that, I mark it wrong because you didn't follow the order of operations. You know, you violated it. You must do this first. And this is 7 times 2 is a hell of a lot easier than 7 times 86 and 7 times 88. What if you didn't have the calculator or you don't have it? What you're going to multiply 7 by big numbers? No. So do the parentheses first. Now, over here, you do 19 times 9, which is 10. On the bottom, you have that -2 just waiting to divide in. It's going to divide. Over here, a -7 times -2 is +14. Now divide 10 by 2, right? It's negative, so you get -5. Then you do 14 minus 5, which is 9. Okay, that's number 5. All right, so number 12, you have parentheses and you have subtraction of fractions. So you make these bottoms the same, and then you combine them into 1, and then you deal with this. So you're looking at 8 and 2. You know, if you need to do this, you may not need to do this, but I'm doing it. I'm looking for the least common multiple. Well, there it is. It's 8. You don't got to make, it's not 16. Do not make both of those bottoms into 16. It's going to get marked wrong. That's not the LCD. So I need to multiply this one by 4. Why? Because 4 times 2 makes 8. So on the top, you get 20, right? 4 times 5. And on the bottom, you get 8. This is all still in parentheses, right? Now that I made the bottoms the same, now I can subtract them. On the top, I get 20 minus 5, which is 15, and you keep the bottom the same. You don't do 8 minus 8. What are you going to do? Put 0 on the bottom. Now, remember how you handle this. Keep, change, flip. This will change to multiplication, and it'll flip over. Now, just put it over here. I flipped it. I'm ready to divide. Now, I taught you a very special technique. If you want to ignore it, it's up to you. I have a 15. 8, I'm going to write as 4 times 2. 28, I'm going to write as 7 times 4. 45, I'm going to write as 15 times 3. Why did I pick 15? Because I have a 15 here. Cross out the 15s, right? 15 divided by 15 is 1. 4 divided by 4 is 1. That's it. I have a 7, a 2, and a 3. Everything else is 1s. 7 is not divisible by 2 or 3. So on the top, you have 1 times 7. And on the bottom, you have 2 times 3, and then you have 1s. So you get 7 over 6. It's not that difficult, but there's a lot of shit to keep track of there. And again, you could screw this question up very easily. You could mess up the adding part. You could mess up the dividing part. Just go through it nice and slow like I did, right? Take your time with it. Still hearing all this yelling. All right, so question 1. Actually, you know what? I'm going to do 6 first because it's the easier one. So distribute. 5 times 4 is 20. 5 times negative x is negative 5. Now, this is a negative 1. Put the 1 there. What's the harm? Negative 1 times 3 is negative 3. Negative 1 times negative 2x is positive 2x. All that equals 38. All right, distribute. Boom, boom. Boom, boom. Here you have a sign switch because you're multiplying by a negative. So it switches. That was plus, becomes minus. That was minus, it becomes plus. Now, put together the things that look the same. You have 2 X's, you lose 5, you lost 3. You have $20 and you lose 3, spend 3, you still have $17 change. Now, what's the strategy? Letter on one side, number on the other side. How? Get rid of this. It's a positive 17. I have to subtract 17 to cross it out. It's not there anymore. But if you want to maintain the balance of the equation, you have to do it to the other side. 38 minus 17 is 21. Now you're done. Divide. Opposite of multiplying is to divide. You divide by the number that you see. Don't switch a sign here. You're dividing by whatever's in front of that X. 21 divided by 3 is 7, and the signs are different, so you get a negative. So that answer is -7. You're doing that question on the final, you get a fraction, you fucked it up. Guarantee you, you don't. You will get positive and negative whole numbers. Every question on that final exam, with the exception of the perfect squares. The difference of perfect squares will be fractions. It has to be. So, but all the two, you'll have 2 equations like this on your final. An easier one and a more advanced one. They both, you'll see, you can do this one. This one's not going to be a fraction. First, I'm going to distribute. Leave this alone. Do not, you can't combine these anyway. They're not even the same. You couldn't subtract them even if this was a 5. You can't do 5 minus 2, right? You have to multiply before you add and subtract. So you do -2 times x, -2 times 6. Combine this side. There's not much. 5x's take away 2x's is 3x's. Combine this side. -18. You owe me 18, but you pay me 2. You still owe me 16. Now you have to decide where you're going with each one. I'm going to eliminate the x from this side. Cross it out. Cross it out. It's not there anymore. Then I'm going to add 12. -12 plus 12. Cross them out. That's 0. But then I have to add 12 to this side. So be careful. 3x's take away 1x, 2x. Equal sign stayed. You see that -12? It's not there anymore. I crossed it out. That's why I crossed it out. -16 plus 12. Right? You have 12. You lose 16. You owe me 4. I divide by 2. Some of you are very good about, writing the steps correctly. Kazi, as smart as he is, never writes these steps like this. He just puts things on one side or the other, and it drives me crazy. I don't want to mark those wrong as long as it's done right. This is organization of your work. Very careful. I don't know why you wouldn't cross out the thing that you cross out. I mean, I add that 12 to cross that out, so I cross it out. Some of you organize your work spectacularly, and some of you don't. All right, so the first one is the multiplication one. Always put a 1 to help you if there's no 1 there, right? So remember, when you multiply radicals, 1 at a time, you multiply the numbers on the outside, 4 times 1, and you multiply the numbers on the inside, and I want to see it. 3 times 3 is 9. Do that. Minus goes along for the ride. Numbers on the outside are 1. You don't have to write the 1, but you can put it. Radical 3 and radical 6 make radical 18. If it bothers you that 1 is there, then don't put it there. But there is a 1 there. Now, 9 is a perfect square. It comes out of jail. When you take it out of jail, what times itself makes 9? 3. Now, I've said it many, many times. You do nothing else. If I see you take radical 9 and write it as radical 3 and radical 3, prove to me that's 3. You can't. You can't. You would have to say radical 3 times radical 3 is radical 3 squared. Radical 3 is 3 to the 1/2 power. 1/2, when you raise a power to a power, you multiply the powers. Now, if you want to do all of this and get it marked right, I'll still mark that wrong because I didn't teach you how to do that. I didn't teach you that the square root is the 1/2 power. You can do nothing else but what I am telling you. So don't do anything else than what I'm telling you. Now, 18 can be written as 9 times 2. And again, put everything together. 4 times 3 over here. 9 is a perfect square. Take it out of jail. Radical 2 is not a perfect. It's not on my list. I didn't write the list, but you know the list, right? 1, 4, 9, 16, 25. Perfect squares come out of jail. You have to take them out. Try again. All right, so radical 35, make it radical 5, radical 7. This is my fault for forgetting to re-record here. Divide the 7s away, right? Radical 7 is 1. So then you're going to do radical 10 times radical 5, which is radical 50. And you'd be like, nailed it. You almost nailed it. The problem is that 50 breaks down more, right? You can write 50 with 25 and 2. 25 is a perfect square. Take them out of jail as 5. And then multiply what's outside the jail, right? 5 times 2 is 10. That radical 2 is stuck in the jail, all right? So split up. It's the same as if you just took radical 7 into radical 35 and wrote radical 5 there. It's the same exact thing. You can split it up with 2. You can write radical 35 as radical 5 and radical 7. Cross out the radical 7s. But you got, this is the important part. You got to make sure you multiply what's left over. And then break it down. It'd be similar to the one on the final. All right, these are the two factoring. All right, there's one more factoring, but these questions, like this one is pretty easy, even though it's got 3 terms. But this question, it looks like a difference of perfect squares because 9 is a perfect square and so is 36. So most people who do this question will just put 3x, 3x, right? And then they'll put 6y, 6y. This is completely wrong. Like, no, it's not. It is. This is a 2-step problem. The first step is to identify the greatest common factor that you can divide out. In this case, it's 9. I can divide these both by 9. So I'm going to. 9 divided by 9 is 1. That leaves me with x squared. 36 divided by 9 is 4. There you go. That's step 1. And I have to see that step. This is the first step. If that step is not there, and the answer is, it's wrong. This step must be there. Now, the 9 has to stay there. But this is the difference of perfect squares now. There's no GCF left. You took it out. It was 9. So x times x is x squared. 2y times 2y, right? Something times itself. One guy gets the plus, one guy gets the minus. If you want to do minus plus, knock yourself out. I don't care how the signs go as long as they're different. All right, so step 1, GCF comes out. Step 2, you keep going. All right, so the next one, you have 3 terms, right? Trinomial. But look, you have 8, 20, and 4. All those numbers are divisible by 4. And you have x3, x2, x2. They're all, right? They have a letter in common. Here's a y, here's a y, here's a y. So remember how you find the greatest common factor with letters. You take the smallest power they have in common. I see y2, y4, y2. That's y2. Now you see a z4. Nobody else has a z. Unless all 3 of them have a z, you can't do shit with that z. So the GCF here is going to be 4x squared, y squared. Not a coincidence. It's always going to, the one on the final, the last term will be your GCF. What do? You put that in the front. Now you put your parentheses. How many things you going to have here? 1, 2, 3. So you better get 1, 2, 3. Very important. Now, if you want to do this, if you want to put it underneath them all, do that. You will probably not get it wrong if you do that. I'm going to cheat. 8 divided by 4 is 2. x3 over x2, right? You lose 1. The y2's cross out. You're left with a z4. Minus 20 divided by 4 is 5. x2 cross out. y4 over y2 is y2. Plus 4 divided by 4 is 1. x2 over x2 cross out. y2 over y2 cross out. 1, 2, 3. 1, 2, 3. GCF. This is the mistake that I see. People do that. They just cross out. They're like, oh, what did you do? You guys know it's an easy mistake to make. All right, so I'm doing 3 as a bonus here. What I'll see is people just write the answer down. But this, again, like this one, this is 2 steps. The first step is to take away the number that they all are divisible by. You have 6, you have 30, and you have 24. Those are all divisible by 6. So you're going to divide every one of those numbers by 6. You get x squared. 30 divided by 6 is 5. 24 divided by 6 is 4. Right? You must divide the GCF out into the front. Now you can factor what's left. So put the x and the x down and then say, what are the signs? Well, they must be the same, and they're both negative, right? You drop that sign, they're the same. There's only two numbers that multiply to 4 that make a 5 when you add them together. If you put 2 and 2, that doesn't make 5. You have to put 4 and 1 to make the 5 in the middle. The problem is that people just do this. How did you get that? Where did that come from? That's bullshit. You go right here, then you didn't do that problem yourself. Real simple. There's no fucking way you went from here to here without that step that I had in the middle. No way. So this used to happen to me when I used to make the videos. I went to try to unpause it, and it didn't unpause, and out here I'm teaching it, and it's not recording. So again, this is not a difficult question. You should nail this question. First of all, I'll make sure these numbers are divisible. Negative 14 divided by 2 is negative 7. So you do that right off the bat. If I were you, I would go circle all of the highest powers. Wherever the power is highest is where that letter will be. If you had y2 on the top and y3 on the bottom, right? Don't you understand that when you cross them out, right? Y divided by y, 1. Y divided by y, 1. Where is this dude left over? On the bottom. That's why you got to start from where it's higher. So here you do 7 take away 4, right? You subtract. The higher power is upstairs, so 7 minus 4 is 3. Now here, 3 take away 2, 1. You can just write y. 8 take away 6, 2. See how they go down? You don't just subtract them mindlessly. You put the letter where the power was bigger. Now, you want to fuck this up? Use negative powers. It's going to be wrong. You don't do that. You know, 6 minus 8, negative 2. I didn't teach you how to use a negative exponent. Negative exponents are undefined. We don't do this at this level. You'll do this in 1275. We don't do this. I didn't teach you to do this. So if I see a negative exponent, I know you're not doing what I taught you. You're not following the class notes. You're not following the class strategy. You're doing something outside of the class, and hence marked wrong. Right, so it's a very simple question. And look, 1, 2, 3. You know I don't like the numbers repeating. So that'll happen on your final. All right, so the 2 solved by factoring ones. There's 3 of them, but these are the 2 I'm doing. This is not equal to 0, right? The goal is set it equal to 0, factor it. So this has to be gone. So I have to do the opposite of it, which is plus 10. You don't put this here. This is nonsense. You don't write this. This is completely out of order. This is not the way that we do this. You have to put it in the middle. It has to go there. It has to be x squared plus 10x minus 24 equals 0. And here's what a lot of you screwed up on, I think it was test 3 and the practice final. Make sure this is there. This equals 0 is there all the way till the end. You're going to put x and x. Now I need 2 numbers whose product is 24 that make it 10. You're going to have a plus 12 and a minus 2. 12 take away 2 is 10. A positive and a negative is a negative, and then 12 times 2 is 24. So I know it works. Set each one equal to 0, right? This was factoring. If the product of 2 things is 0, one of them must have been 0. You can't skip these steps. This is your work. As dumb as it is, and as easy as it is, and you think it's stupid to write that, all of it. Everything has to be written. You want to get this question correct. If any of those steps are not there, if you jump from here to here, it gets marked wrong. If you put this plus 10x at the end instead of in the middle and somehow magically you factored it right, it gets marked wrong. It's going to get marked wrong if those steps are not there in that order. Okay? Now this one, same thing. Step 1, set it equal to 0. Subtract the 16x over to the other side, equals 0. I don't know how to factor this. You can't factor this. This is a perfect square, but this isn't. This is a GCF. I'm looking for the largest number that divides them both. So 2, yes. 4, yes. 8, right? Take the 16, cut it in half. 16 is divisible by 8, but 12 isn't. 16 is divisible by 4, and 12 is also divisible by 4. So you're going to divide 4, and you're going to divide the x out. So put 4x in the front. And then again, if you need to, do this. 12 divided by 4 is 3. X squared over x leaves you with 1. Minus 16 divided by 4 is 4. The x is crossed out. Equals 0. If the product of two things is equal to 0, then one of them must be 0. So either that one, my straight mark there, or that one. Now this is where you're multiplying a number by 4 and you got 0. That number can only be 0, right? Divide both sides by 4. 0 divided by 4 is 0. Here you have to add the 4 over first and then divide by 3. These are the steps that Kazi never likes to show. 2 answers, both of them. So question 20 is, I don't want to say it's a gift, but it's not difficult. Everywhere you see x, you put -1, right? You are checking if it's a solution. Just like on the final, you will not be plugging in -2. You will not be plugging in anything other than -1. Now you're going to do -1 to the 3rd power. That's -1, right? 1 times 1 times 1, and you have 3 negative signs, so that's negative. -4 times -1 is +4. Remember, one side at a time. Now, I have a +4, add up the negatives, right? -1. You lose 1, you lose 7, you lose 8. That's -4. So now I got my left side done. Now go to the right side. I want you to work like this. -1 squared is 2. 1. -1 times -1 is +1 times 2. Right? Square a negative. Negative times a negative is plus. 1 times 1 is 1. 9, +9 times -1 is -9 plus 3. Now 2 times 1 is 2. So add up your pluses, right? You have +2 times 1, which is 2, plus 3, which is a +5, and then you're going to take away 9. But 5 take away 9 is -4. Yay! You get your yes. All right, so that's a yes. Very simple. Very simple. Just plug the number in, get the number on both sides. And I already told you, the one on the final is a yes.